Welcome to Senior High School Math Series. Let us have Ellipse Part 2 with center at HK under Precalculus Q1 Week 3 based on curriculum implementation and learning management matrix for K-12's most essential learning competencies. Part 1 of the video lesson on ellipse has been uploaded prior to this video. If you haven't seen it, the link is on the description of this video. Let us have a recall of the definition of an ellipse. An ellipse is the set of all points P in a plane such that the sum of the distances of P from two fixed points of the plane is a constant. The two fixed points are called foci of the ellipse. The equation of the ellipse with center at origin and major axis along the x-axis is given by x squared over a squared plus y squared over b squared equals 1. While when the major axis is along the y-axis, the equation for the ellipse with center at origin is given by x squared over b squared plus y squared over a squared equals 1. Now, if the axes of an ellipse are parallel to the coordinate axis and the center is not at the origin but at an arbitrary point HK on the Cartesian plane, we can obtain its equation by applying the translation formulas. We draw a new pair of coordinate axes along the axis of the ellipse. We have y prime and x prime. In here, we see that the major axis of the ellipse is now parallel to the x-axis, and the distance between the center and the vertex is a units. Also, the distance between the center and a co-vertex is still b units. The relationship between a, b, and c is still c squared is equal to a squared minus b squared, where c is the distance between the center of the ellipse and a focus. And the equation of the ellipse referred to the new axis is given by x prime squared over a squared plus y prime squared over b squared equals 1. The substitutions x prime is equal to x minus h and y prime is equal to y minus k from the translation formulas yields the equation of the ellipse with center at HK and major axis parallel to the x-axis as x minus h squared over a squared plus y minus k squared over b squared equals 1. Now let us have the equation of the ellipse with center at HK and whose major axis is parallel to the y-axis. Still, we have the new axis drawn from the axis of the ellipse. We have the center at HK. The distance between the center and the vertex is a units. The distance between the center and a co-vertex is b units. Still, the relationship between a, b, and c is c squared is equal to a squared minus b squared, where c is the focal distance, and the equation of the ellipse is x prime squared over b squared plus y prime squared over a squared equals 1. Again, from the translation formulas, x prime is equal to x minus h and y prime is equal to y minus k. We have the equation of the ellipse with center at HK and whose major axis is parallel to the y-axis as x minus h squared over b squared plus y minus k squared over a squared equals 1. Let us have the properties of an ellipse with center at HK and whose major axis is parallel to the x-axis. The equation is x minus h squared over a squared plus y minus k squared over b squared equals 1, where a is the distance between the center of the ellipse and a vertex, and b is the distance between the center of the ellipse and a co-vertex. Hence, the coordinates of the vertices of the ellipse will be at h minus ak and h plus ak. The distance b prime is the major axis of the ellipse, and that is of length 2a. The coordinates of the co-vertices of the ellipse will be at hk minus b and hk plus b. The distance b prime is the minor axis of the ellipse, and that is of length 2b. The center is at hk. The distance between the center of the ellipse and a focus is equal to c units. The relationship between a, b, and c is c squared is equal to a squared minus b squared. The coordinates of the foci will be at h minus ck and h plus ck. The chords of the ellipse perpendicular to the major axis and passing through the foci are called the latus rectum of the ellipse. The ends of latus rectum are with coordinates h minus c k plus or minus b squared over a and h plus c k plus minus b squared over a. The length of the latus rectum is equal to 2b squared over a. This time, let us have the properties of the ellipse with center at hk and whose major axis is parallel to the y-axis. The formula is x minus h squared over b squared plus y minus k squared over a squared equals 1. The coordinates of the vertices are at h, k minus a, and h, k plus a. The major axis is of length 2a. The coordinates of the co-vertices are at h minus bk and h plus bk. The length of the minor axis is equal to 2b. The center is at hk. The foci will be at h, k minus c, and h, k plus c. The ends of latus rectum will have the coordinates h plus minus b squared over a, k minus c, and h plus minus b squared over a, k plus c. The length of latus rectum is 2b squared over a. Let us have example number 1. Find the equation of an ellipse with foci at 4, negative 2 and 10, negative 2 and the vertex at 12, negative 2. Let us have our solution. We know that the foci, the vertex, and the center of the ellipse are collinear. Since the foci and the vertex have the same y coordinates, we have an ellipse whose major axis is parallel to the x-axis. And the standard form of the equation is x minus h squared over a squared plus y minus k squared over b squared is equal to 1. Hence, to get the equation of the ellipse, we need to get the coordinates of the center, the distance between the center and the vertex, that is A, and the distance between the center and a covertex, that is B. Since the center is midway between the foci, we can get the coordinates of the center using the formula for midpoint. Hence, we have 4 plus 10 over 2, comma, negative 2 plus negative 2 over 2. So we have the coordinates of the center as 7, negative 2. A is equal to the distance between the center and the vertex. Since the center and the vertex 12, negative 2 have the same y coordinate, A is equal to the absolute value of the difference 12 minus 7. Therefore, A is equal to 5. The distance between the foci is equal to 2c, and that is equal to the absolute value of 10 minus 4, since we have the same y coordinates. So 2c is equal to 6. Dividing both sides by 2, we have c is equal to 3. To get the value of b, we will use the relationship c squared is equal to a squared minus b squared. In this equation, we will substitute a equals 5 and c equals 3. So we have 3 squared is equal to 5 squared minus b squared. 9 is equal to 25 minus b squared. And b squared is equal to 25 minus 9. That is equal to 16. Getting the square root of both sides, we have b is equal to 4. Hence, the equation of the ellipse is given by x minus 7 squared over 25, that is 5 squared, plus y minus negative 2, so we have y plus 2 squared, over 16, that is from b is equal to 4 and b squared is equal to 16, equals 1. Example number 2. Find the equation of an ellipse with foci at 2, negative 4 and 2, 4. Major axis is 10. Let us have our solution. This time we have an ellipse with foci at 2, negative 4 and 2, 4. Since the x coordinates are the same, then we have an ellipse whose major axis is parallel to the y-axis. The standard form of the equation is x minus h squared over b squared plus y minus k squared over a squared equals 1. Still, to get the equation of the ellipse, we need to get the coordinates of the center and the value of a and b. The center is midway between the foci. Hence, the coordinates of the center will be 2 plus 2 over 2, comma, negative 4 plus 4 over 2. The center, therefore, is at 2, 0. The distance between the foci is equal to 2c. Therefore, we have 2c is equal to the absolute value of 4 minus negative 4. 2c is equal to 8. Dividing both sides by 2, C is equal to 4. The length of major axis is equal to 2a. Therefore, we have 2a is equal to 10. Dividing both sides by 2, we have a is equal to 5. To get the value of b, we will use the relationship b squared is equal to a squared minus c squared. And then we have b squared is equal to 5 squared minus 4 squared. B squared is equal to 25 minus 16, and that is equal to 9. Hence, we have b is equal to 3, and the equation of the ellipse will be x minus 2 squared over b squared, that is 9, plus y minus k squared, and k is 0, so we have y squared over a squared, that is 25, equals 1. Example number 3. Reduce to standard form the equation 4y squared plus 9x squared minus 24y minus 72x plus 144 equals 0. Then identify its properties. In here, we are given the equation of the ellipse in its general form. And to reduce this to its standard form, we're going to collect the terms with variables y and x. So we have 4y squared minus 24y plus 9x squared minus 72x. And let us first subtract 144 from both sides so that the right-hand side will be negative 144. Rewriting 4y squared minus 24y, we can have 4 times the quantity y squared minus 6y. Let us leave a space to complete the square in y squared minus 6y. Also, 9x squared minus 72x can be written as 9 times the quantity x squared minus 8x. Also, let us leave a space so that we can complete the square trinomial in x squared minus 8x. The right-hand side is negative 144. Completing the square in x and y variable, we have negative 6 divided by 2, that is negative 3 squared, so we have 9. Then we added 4 times 9 to the left-hand side of the equation. We will also add 4 times 9, or 36, to the right-hand side. In x squared minus 8x, to complete the square, we have negative 8 divided by 2, that is negative 4. Square, that will be 16. Hence, we added 9 times 16 to the left-hand side. To the right-hand side of the equation, we will also add 9 times 16, and that is 144. 4 times the quantity y squared minus 6y plus 9 can now be written as 4 times the quantity y minus 3 squared. Also, 9 times the quantity x squared minus 8x plus 16 can be written as 9 times the quantity x minus 4 squared. Negative 144 plus 144 is 0. What is left on the right-hand side is 36. Notice that in the standard form of the equation of the ellipse, the right-hand side is equal to 1. So to make the right-hand side of this equation equal to 1, we will divide all terms by 36. Then we have y minus 3 squared. 4 over 36 is 1 over 9, so we have over 9. Plus x minus 4 squared. 9 over 36 is 1 over 4, so we have over 4 equals 1. We now have the equation of the ellipse in its standard form, and since 9 is in the denominator of y minus 3 squared. We have an ellipse whose major axis is parallel to the y-axis. The center from the standard form of the equation is at 4, 3. Also, from the standard form of the equation, we have a squared equals 9, then a equals 3. B squared is equal to 4, then b equals 2. From the relation c squared is equal to a squared minus b squared, then we have c squared is equal to 9 minus 4, then c is equal to square root of 5. Now let us have the other properties of the ellipse. The vertices will be at 4, 0, that is 4, 3 minus 3, and the other at 4, 6, that is at 4, 3 plus 3, so we have 4, 6. The length of the major axis is 2a, so that is equal to 6. The co-vertices b prime will be at 2, 3. That is 4 minus 2, 3. And the other co-vertex at 6, 3. That is 4 plus 2, 6. And then y-coordinate is 3. The length of the minor axis is equal to 2b, so we have 4. Since c is equal to the square root of 5, the coordinates of the foci will be at 4, 3 minus square root of 5, and the other at 4, 3 plus square root of 5. Then we have the ends of LR. We have h plus minus b squared over a, k minus c, and also h plus minus b squared over a, k plus c. Hence, the ends of LR will be at 16 over 3, 3 minus square root of 5, 8 over 3, 3 minus square root of 5, and then 16 over 3, 3 plus square root of 5, also 8 over 3, 3 plus square root of 5. The length of LR is equal to 2b squared over a, so that will be 2 times 4 over 3, that is 8 over 3. Example number 4. Reduce to standard form the equation x squared plus 4y squared minus 6x minus 16y plus 21 equals 0. Find a, the coordinates of the center, b, the foci, c, the ends of major axis, and d, sketch the graph of the ellipse. First, let us reduce the equation of the ellipse to its standard form. So we have x squared minus 6x plus 4y squared minus 16y. Subtract 21 from both sides. The right hand side will be negative 21. Completing the square in x squared minus 6x, we'll have x squared minus 6x plus 9. 9 is obtained from negative 6 divided by 2 square. Then we have 4 times the quantity y squared minus 4y. Completing the trinomial, we have y squared minus 4y plus 4. And 4 is from negative 4 divided by 2 square. Completing the square in variables x and y, we added 9 and 4 times 4, 16 to the left-hand side of the equation. Hence, we also have to add 9 and 16 to the right-hand side of this equation. X squared minus 6x plus 9 can be factored as x minus 3 squared, while y squared minus 4y plus 4 can be factored as y minus 2 squared. On the right-hand side, we have negative 21 plus 9 plus 16, we have 4. Dividing all terms of this resulting equation by 4 so that the right-hand side will be equal to 1, we have x minus 3 squared over 4 plus y minus 2 squared over 1 equals 1. The denominator of the x terms is greater than the denominator of y terms. Therefore, we have an ellipse whose major axis is parallel to the x-axis. Letter A, the coordinates of the center will be 3, 2. Letter B, to get the foci, we need to get the value of c. And since c squared is equal to a squared minus b squared, then we have c squared is equal to 4 minus 1, that is equal to 3. Hence, c is equal to the square root of 3. Since the major axis is parallel to the x-axis, the foci will be at coordinates 3 minus the square root of 3, 2, and 3 plus square root of 3, 2. The ends of the major axis for letter C are the coordinates of the vertices. And since A is equal to 2, from A squared equals 4, then we have the ends of major axis as 3 minus 2, that will be 1, 2, and the other at 3 plus 2, that will be 5, 2. Next, let us show the graph of the ellipse. So we have the y-axis, also the x-axis. We have the center at 3, 2, a vertex at 1, 2, and another at 5, 2. Since B is equal to 1, then a co-vertex at 3, 1, and also at 3, 3. Hence, we have the graph of the ellipse.
Let us have example number 5. The perimeter of a triangle is 14, and the points negative 3, 2 and 3, 2 are two of the vertices. Find the equation of the graph of the third vertex. In here, we are given 2 points. These are negative 3, 2 and 3, 2. Let us start by plotting these points on a rectangular coordinate system. So we have the y-axis and the x-axis. Plotting negative 3, 2, we have negative 1, negative 2, negative 3 on the x-axis, and then positive 2 on the y-axis. Also, we have positive 3, positive 2. And these are two vertices of a triangle according to the problem. The distance between these 2 points is 6. They have the same y coordinates and different x coordinates, so we just get the absolute value of the difference between the x coordinates. So the distance between the 2 points is 6. That means one side of the triangle is 6. Let us choose an arbitrary point on the rectangular coordinate system and have it as the third vertex of the triangle. Let us connect the other two vertices to that point, then we will have the triangle. We're looking for the equation of the graph of the third vertex. That means the third vertex may be located at different points on the rectangular coordinate system, and if we trace those locations of the third vertex, the trace of the third vertex would create or would form an ellipse. Hence, we are looking for the equation of that ellipse traced by the third vertex of the triangle. By this, we'll have the 2 points negative 3, 2 and 3, 2 as the foci of that ellipse. Therefore, the two foci have a distance of 6. So we have 2c is equal to 6. And the remaining length of the two sides of the triangle would sum up to 14 minus 6, and that will be 8. Hence, this is 2a as equal to 8. Getting the value of a and c, we'll have c is equal to 3 dividing both sides by 2, and a is equal to 4 dividing both sides by 2. From the trace curve by the third vertex, we have an ellipse that has its major axis parallel to the x-axis. Hence, we're looking for the standard form of the equation of that ellipse as x minus h squared over a squared plus y minus k squared over b squared equals 1. Now we already have the value for a. We'll be looking for the value of b and the center hk. From the relation, a squared is equal to c squared plus b squared, we'll have a is equal to 4, so a squared is 16, c is equal to 3, so c squared equals 9, plus b squared. B squared is equal to 7. Now we already have the value for b squared, and that is 7. Now looking for the center of the ellipse, that would be the midpoint of the two foci. So the midpoint of negative 3, 2 and 3, 2 will be negative 3 plus 3 over 2 and 2 plus 2 over 2. That is the sum of the x coordinates over 2, comma, sum of the y coordinates over 2. Therefore, the center of the ellipse is at 0, 2. Now we already have the value for a squared, b squared, and the center. Therefore, the equation of the graph of the third vertex is x squared over 16, that is 4 squared, plus y minus 2 squared over 7, that is b squared, equals 1.
That will be all. Exercises on this topic may be downloaded from the link given on the description of this video. Thank you for watching. Please subscribe for more math lessons.